Okay, welcome to another round of tensile testing. This time we're going to do PETG as opposed to PET from the earlier ones. And this time we're going to do a couple of different colors. So here's our gray, and I'm using Overture because I want to, because I have that in 4 different shades. And what I wanted to test is, does color affect tensile strength? And I've heard that it does, but I don't have any actual uh, information on whether or not that's true. So that's part of why I built this. We're going to see. Okay, so I'm going to start the test. BETT, Overture, Gray, XY axis. All right, let's get going. In case you're curious, the clamp is PA6 with glass fiber polymaker. That is currently my strongest filament that I've tested. So, of course, make the test clamp out of that. Okay, what was that, about 1400? Yeah, just over 1400 newtons. Gonna do 5 trials. Trial 2. It's right about the same. Trial 3. I have a stopper on the jack so that it goes back down to the correct place for me to set up the next round. That saved me a lot of time. And of course, all the files for printed parts are in the GitHub page. That will be in the video description and also the pinned comment. Okay, those were the XY tests. Get the test results here. All right, about 57 megapascal. So that is the number of newtons divided by the cross-sectional area, which on the uh, XY test is 25 square millimeter. Okay, so let's set it up for Z, ETG over to grade Z. And the Z axis is a little bit thicker test part. All right, that's pretty good. Comparatively speaking, TETG seems to have pretty good Z axis strength. A little over 1100 newtons there, 50 square millimeter cross section at the narrowest part. Not quite as strong on that one. Definitely feel it in the jab. To apply pressure very smoothly. Not trying to shock load this. All right, let's see where the numbers come in. Okay, 21.5 megapascal. All right, let's go on to the next. Okay, next one is going to be white. And I had one loss. The printer knocked that over towards the end. So I'm going to have to remember, although I probably won't. Well, actually, you know what? I'm just going to do a 5. We'll see if it fits in the fixture. I will probably forget to set the trials to 4 anyway. Okay, white, XY. Off to the races. That's right. Yeah, I've heard that white pigments make parts weaker than other colors, but I don't think that's true. That seemed right about where the gray was at. Yeah, that's pretty close to 1400. And something. Now this highlight jack gives me plenty of lever arm, so it's not actually hard to push down. I'm just trying to get it really smooth. All right, let's see where this comes in. 54, 54 and a half, and the last number was 56.85. Okay, so it's a little bit weaker, but boy, not by much. Like I think we're kind of within the margin of error there. Okay, Z, let's go. That was about 1,300 newtons. That's a pretty good trial. Okay, now this one might or might not stay in the clamp. We will see. Okay, 900 something, and it did break. It did just fall out. Okay, 21 and a quarter compared to our previous value of 21 and a half. Okay, so I'm going to say that white was about the same as the gray. So now we have a dark blue. Again, Overture PETG. Blue XY. What that means is that this is printed in the XY orientation as opposed to vertically off the print bed. So we're pulling with the perimeters of the printer as opposed to across them. Okay, this is going to be a pretty boring test because it looks like all the numbers are coming in right about the same. Of course, most of these tests are pretty boring to start with. Okay, 54.3 on the XY. That's again right about where the others were. Blue Z-axis. Let's go. You may notice in my software that it will say below threshold as long as it's below 50 newtons. So it waits until the fixture starts to load up. And then, because actuating the jack will make the force drop down, like when I pull it up to crank it again. So it continues measuring until it's been below threshold for 10 seconds. Once it's been below threshold for 10 seconds, it automatically resets to the next trial. Or exits and logs. So just saves time. All right, blue, trial 4. All right, wait for this to exit out. Okay, 21.2 megapascal for z-axis, and it was 21.2 last time. Okay, so this is a whole bunch of nothing interesting. All right, yellow's our last one. Yellow, X, Y, off the races. Building up quite a pile of carnage down there. All the test samples. Okay, I think it's going to be right around 1400 newtons again. Pretty close. Okay, z-axis, last 5 guess here. That one was weaker by a bit. Oh boy, there's a z-axis. One to have a oh, that probably didn't print that great. In fact, they kind of printed, or I'm sorry, they broke. That one broke up there, which is not the narrowest part. In fact, quite a number of these broke up high. I'll show you that on camera here in just a minute. Huh. Well, yeah, it was kind of weird. Let me get this out. Okay, so that was substantially weaker than the rest, but I'm not sure if it was due to color or not. So all five of these broke up at one side, and that is weird. That I can't explain. And oh, okay, look. So they're marked at one end with a Z and a 50. So I know that it's the Z axis and 50 millimeter, 50 square millimeter cross section. And sorry if the light's kind of weird here, but they all broke at about the same height and on the same end. So that's telling me there was something wrong with the printing right around that layer. Yeah, they all broke at just about the same place. So I don't know if that was a uh, filament problem or a printer problem or a what, but I'm gonna say that the yellow z-axis test is not good. That we had something else that wasn't just tensile strength going on. Okay, so that was the last of my testers. Got a big mess as usual. Thanks so much for joining me, and all the tests will, or all the test results, all the files for this, they're on my GitHub page. Thanks a bunch.